Hello, today we're going to continue on with our study in triangles, and we're going to take a break from proofs and instead look at some of the patterns that we can uncover in common triangles. Now, with this, the goal that we have is to find out as much information as we can using just a few pieces of information. And we did that already when we were looking at congruent triangles. When we were able to tell that two triangles were congruent to each other, well, that told us a ton of missing angle measures and a ton of missing side measures because we were able to tell that other sides and other angles were now congruent. The same thing is going to be true when we're looking at types of triangle. Just a few pieces of information can lead you to a lot of other conclusions. So let's look at isosceles and equilateral triangles. And we're going to start today with the equilateral. When we're talking about an equilateral triangle, all of the sides are equal. But turns out in triangles, when all of the sides are equal, all of the angles will be equal as well. And since the angles of a triangle add up to 180 degrees, I can add these up to get 180. Which means every single one of these would have to be 60 degrees since they are all equal angles. Now, the equilateral then automatically gives us each measure of the angle. An isosceles triangle won't be quite that straightforward, but it does still give us a lot of information. First off, as soon as I see these two markings, where two sides are congruent in a triangle, I know I have an isosceles triangle. It doesn't need to be labeled, it only needs those two marks. The other thing I know automatically is the side that is not for sure equal is called the base, and it's going to be opposite our vertex angle. Now, with this base comes with two angles attached, and we call these the base angles. And in an isosceles triangle, it turns out that the base angles are always going to be congruent to each other. That ends up giving us then a lot of information for solving. Outside of that, I also have one other thing that I can uncover in this, and that has to do with a special line in this triangle called the median. The median of a triangle is the segment that connects the vertex to the midpoint. You can see that is then this line here from A to the midpoint of the base. And in an isosceles triangle, we're going to have a very special case because not only does this come down to the exact midpoint of the base, it also hits at a 90-degree angle. And because it's hitting the midpoint, I know that these two sections from B to this midpoint and from C to this midpoint are going to be equal as well. Now, while that is true in all triangles, that it will, of course, come at the midpoint and split it into two equal sections, it is not always true that it will come at a 90-degree angle. In fact, it's only going to do that when we have an isosceles triangle. So this triangle right here, because this median is not coming at 90 degrees, I know that this could not be an isosceles triangle. There's one other special thing about this median, and that is that it's always going to be the angle bisector of our vertex, provided, of course, we are using an isosceles triangle. So that means I get a lot of information just by this. And it also means that I have a lot of new ways to figure out if something is an isosceles triangle. For instance, if I was given this drawing, I know that I have an isosceles triangle because I have two angles that are congruent, making these two sides also congruent or part of an isosceles triangle. So watch for these pieces of information because just a little bit of information can get you a long way. And let's see what we can do with these formulas. So we're going to go through and solve for some missing sides and missing angles. So when I'm solving for these, I'm going to start with just looking for where my base is. And remember that the base is just the side that we don't know for sure is the same length as the other two sides. And then using the base, I can mark in the two angles on the base as congruent because this is an isosceles triangle. So that means y would have to equal 52 degrees. However, I'm still missing an x. But if I remember my formulas for triangles, I know that all of the angles added together have to equal 180. That means that if I take my two base angles of 52 degrees and add them to my vertex angle of 14x plus 6, I have to get 180 degrees. And in this case, I can then solve for x, combining my like terms to get 110 plus 14x is equal to 180. Subtracting 110 from both sides, I then know that 14x is equal to 70. When I divide by 14, I now know that x is equal to 5. And I have my two answers. But of course, triangles will also give us information about sides. So if I look at this picture, I do know, of course, that these angles are congruent because they are the base angles. But the information given to me is not about my angles. The information given to me is about my sides. And I know for sure it's talking about a side here because there is no degree sign like they do over here. So this side is 2x minus 9 and this side is x plus 9. Since the two sides are congruent, I can set up an equality because we know that congruent sides have equal measure. Once I have that, I can solve for x by adding 9 to both sides and subtract x from both sides, leaving me with x is equal to 14. For this one in the corner, notice that the angle given to us is a vertex angle, and our base is actually not at the bottom. That's okay, because the only thing that determines what is the base is the markings on the other two sides. It doesn't matter if it's on the bottom from what we're looking at. So since this is our base, that means that these two angles are our base angles, and they will not be equal to this last one. And I know they can't be equal to this last one because if they were equal, all of these angles would have to be 60 degrees, not 63. That doesn't mean, however, that I cannot solve for this angle. There are a couple ways you can do it. First, you can say that this is just x, an unknown number, and therefore this is that same unknown number. And using those three angles, you can set up a formula saying x plus x, this angle plus this angle, plus 63 degrees is equal to 180 degrees. And from there, you get 2x is equal to, or plus 63 is equal to 180. Subtracting 63 from both sides, you end up with 2x is equal to 117, which means just x is going to be 58.5. And this won't be a degree because it is this will be a degree, sorry, because it's the entirety of that angle. But we've left the hardest one for last. Using everything that you know about triangles, you're actually going to be able to solve for a lot of different missing angles. But one thing you have to watch out for is really just being overwhelmed. There is so much information in this triangle, and it's asking for this angle right here. But if I'm looking at the information given versus the angle I'm looking for, well, the triangle that angle is in really doesn't have much information. It only has a 90-degree angle and no sides, no other angles, and I know I can't solve for it then. So what I'm going to do is I'm going to actually look for a place where I have a nice number to work with, an easy number to work with. And then I'm going to look for what sort of shape it is in and see if I can find more pieces of information that can bring me closer and closer to that angle that I want. And I won't worry too much about where that information is taking me yet, provided I'm still learning something new and finding something new. In geometry, you can trust that that will bring you somewhere interesting and eventually to the answer that you need. So let's look at this 66. Now, if I look at the 66 in the triangle that it is currently in, well, I can see that this triangle is isosceles, and this AB is the base, which means that I can draw in my base angles as congruent to each other. Since C is 66 degrees, that means my base angles will add up to with 66 to make 180 degrees. That means that my 2x will be equal to 180 minus 66, or 114, which means just my x here is going to be 114 divided by 2, which is going to be 57 degrees. Well, now that I know what this angle is, I can mark it in, 57 degrees. But, you know, while that has gotten me closer to the angle in this right triangle, I'm still not going to be able to quite figure out what it is from here because these two angles don't look to be equal, nor do I have anything that tells me they're equal. I can see that I do have a straight line here, which will be 180 degrees, but 57 is not enough information to figure out what one of these angles will be. So what I'm going to really need to do is I really need to figure out what this angle is. And so I'm going to look at what other information I have. Well, I've been told that this triangle CBD is a right triangle, with C being the right angle in that triangle. I also noticed that the markings here tell me that this right triangle is isosceles, which means its base angles will be congruent. Since this angle is then 90 degrees, it means that these two angles will have to be 45 degrees each. And that is because the sum of all three of these angles has to equal 180. And that means that we have 90 is equal to 2x, or x, that final angle. We'll call it y this case, so that we have a different variable there. That final angle is going to just be 45. Now I have two angles, and I'm getting closer. And in fact, I have an angle that's right next to a little question mark. I just don't know what those angles add up to, so this one doesn't help me a ton. But if I look down here at my straight lines, and always look for straight lines when you're dealing with angles and triangles, because they usually give you that extra bit of information. When I'm looking at this straight line, I notice that these three angles, 57, 45, and this unknown one, have to add up to 180 in order to form a straight line. So I'm going to call that angle Z, just so I have a different variable going on. And I'm going to go ahead and subtract from 180 the 53 and the 45, leaving me with Z is equal to 82 degrees. Well, if Z is equal to 82, and Z is the measure of B here, then that means that what I have is an 82 degrees here, the angle that I actually want over here, and a 90 degree in the corner. So the sum of these three angles has to be 180, which means 82 plus 90 plus my unknown is going to equal 180. And when I subtract 90 from 180, I get 90. Subtract 82 from 90, and I'm going to get that final unknown angle is equal to 12 degrees. And I know I need the degree sign here since it is an angle all to itself, not simply something I am substituting into a formula. So that is it for our lesson today. Your homework is attached on Classroom. I hope you have a wonderful weekend.